Okay, we're going to do number 1 and 2 on the review. So we are just graphing. This is vertex form, meaning the vertex is going to be what's easiest for us to pick out. So to find the x-coordinate, I just take the opposite of what is in parentheses. So this is going to be a positive 4. And then the y is just whatever number's out here. So that is going to be positive 2. So 4, 2. There is my vertex. Now, all I ever need to graph is the vertex and the a value. So here my a value is 1/2. And now I'm just going to follow the 1a, 3a pattern. 1a is just 1 times 1/2. Well, that's a half. So I'm going to go over 1, up 1/2 on both of these. 3a, it's going to be 3 times 1/2. So that's 3/2. You can type that into your calculator. If you want to make it a decimal, it's going to be 1.5. So I'm going to go over 1, up 1.5.
Like this?
Over 1, up 1.5. And then I have my 5 points where I can make my graph. Okay, so that covers the graphing portion. And now, honestly, to find all of these key features, I'm just going to look from the graph itself. So x-intercepts, I'm looking where does it cross the x-axis. Oh, doesn't have any. Best day ever. Now I don't have to do work. The y-intercept, I can't quite see it. So I have a few options. I can keep following this 1a, 3a, 5a pattern until I get it. I can also plug in 0 for x. Because the y-axis, the x-coordinate is 0. And if I know the x-coordinate, then all I have to do to find the y-coordinate is plug it in. So 1/2 times 0 minus 4 squared plus 2. Can you use a calculator for this? Yes. Yes, you can. It's highly encouraged because it makes your life easier. 1/2, 16 plus 2. But I'm already doing it by hand, so why stop now? So 0, 10. Okay, axis of symmetry. That is just the x-coordinate of your vertex. It has to be x equals. If you do not put x equals, you will be wrong. Okay, your maximum or minimum value, this is just your vertex, and this specifically wants the y of the vertex. So that's going to be 2. The x value that maximizes or minimizes the function, well, guess what? That's going to be your x-coordinate of the vertex. Okay, domain for parabolas is always going to be negative infinity to positive infinity. We could also write that as all real numbers. Or in inequality notation, domain is looking at the x. So I'm going to put x, put it between 2 less than, greater than signs, and then it's going to be negative infinity on the left and positive infinity on the right. The range is looking at the y values, and this is always written from lowest to highest. So my lowest was 2, and then it just goes up forever, so that goes to infinity. And range, I actually need a bracket on the number because it is for sure hitting that point. Range is the only one where we need brackets. I'm putting this in the inequality notation. I looked at y this time and went from 2 to infinity, but it has to be or equal to, that's the same as the bracket. You'll also be seeing it as just like this, so y greater than or equal to 2. So just beware that will also happen. Okay, as far as increasing, decreasing intervals go, I'm just looking, I'm going to draw in my axis of symmetry, and I'm just looking which side has the positive slope for increasing. So looking from left to right, I see here, this ends down, so that is negative, so that's decreasing. But here, this side ends up, so that's my increasing side. So that started, I'm going to grab a different color, that started right here at 4, and will keep going forever. So that actually is from 4 to infinity. So once again, I looked at my x's, went 4, infinity. You could also see that as x greater than 4. And decreasing, here's a different color. Decreasing was this other side. Came in like that. So that was from negative infinity to 4. I was looking at x, so it's negative infinity 4. And this parabola open up. That was nice.